All right, so today's lesson, this is 5.3 and 5.4 for our next unit on energy transformations. So 5.3 is understanding energy conversions. All right, so energy, we talked about last class, the ability to do work. So to do work, energy constantly changes from one form to another. Energy that enters a system, that's called the input energy. Then there's the system where energy is changed from one form into another. That's called the converter. And then the energy that leaves the system is called the output energy. So if we look at this example, we have the flashlight. The input energy here is the input energy. That would be the chemical energy from the battery. Then we have the converter here, which would be the flashlight bulb. And then the output energy, which will be the light energy that is being produced. Last question here, is thermal energy given off? Yes, thermal energy as heat is always given off as waste. When is thermal energy wasted? Thermal energy is released during most activities. In many cases, it is wasted energy. It's not used or needed for the activity, and it can become a problem. For example, on extremely hot days. For example, if there's an athlete outside in the extremely hot day, they can get overheated. Many machines also produce excess thermal energy, and this thermal energy can actually start to interfere with their operation. So think about like car engines. If they get overheated, the car will stop running. Here we're looking at input energy. We're looking at the muscles in the body. So the input energy would be the chemical energy stored in the glucose in the muscle tissue. Athletes usually train so that their muscle tissue will convert energy in the most efficient way possible. So energy conversion occurs at the cellular level. Glucose gets transported to the muscle cells by the blood. The mitochondria, or the mitochondria in the cells, is the converter. The chemical energy in glucose is converted into another form of chemical energy that can be used for a specific purpose, such as muscle contraction. And then the output energy here is the movement of the muscle cell. Muscle cells move by contracting. Again, just like any other energy system, the conversion of energy from one form to another, it's never 100% efficient. Some of that energy is going to be released as thermal energy or heat. So for example, looking at these athletes here, the body will warm up during heavy exercise. And again, that could be problematic if, for example, if it's a really hot day. So chemical conversions, the heat that we feel during exercise, it's produced by a chemical reaction within the muscles of the body. Potential energy from food is converted to thermal energy, and many chemical reactions also produce thermal energy. So for example, the potential chemical energy from food gets converted to kinetic energy for muscles to move. Potential chemical energy from food is also converted to thermal energy to keep us warm. About 84% of Alberta's electricity is produced by burning coal, and this combustion of coal produces a very large quantity of thermal energy. And around the world, this chemical reaction has also been identified as the cause of acid deposition and climate change. Another example here, we have commercial hot or cold packs. They contain chemical potential energy. When the pack gets twisted, a small container inside, the pack breaks, the ingredients will mix together, and then depending on those ingredients, heat will either be given off or absorbed to become a cold pack. Here, the concrete used in foundations and sidewalks and to hold bricks together undergoes a chemical reaction as it hardens. So at first, the cement powder and water and sand and gravel are mixed together and it can be poured. But as the mixture sets, it gives off thermal energy and then hardens. So when is thermal energy wasted? We already did do this slide already, so I'm just going to skip it. And we have the questions for 5.3, page 91, number 1 to 3. All right, so next we are looking at 5.4, which is conservation of energy. So in this example, we're looking at a blow dryer or a hair dryer. What types of energy are produced by a blow dryer? So the thermal energy provides the heat to dry your hair. So there's kinetic energy in the moving air. Some of the electricity is converted to sound energy. The glowing elements produce light energy. The fan that moves the air is the motor. There's also friction that produces thermal energy that is not actually used to dry your hair. You can measure the electricity that goes into your blow dryer, and then if you compared it to all these forms of output energy, you would find that the two are equal. So input energy is always equal to the output energy. And the reason being is because of this law of conservation of energy, which states that energy cannot be created or destroyed. Energy is only changed from one form of energy to another. All right, so for any energy conversion, the amount of input energy is the same as the amount of output energy. Many people spend lots of money trying to design a machine that will run by itself. It's called a perpetual motion machine. And basically it would run on and on without any maintenance or any fuel. Wouldn't that be nice? But there cannot be such a thing, because for a perpetual motion machine to work, it would have to have no waste energy, no thermal energy as waste. So far, no one has found a mechanism that does not lose at least some energy to heat or friction. All right, so there is a video here on why don't perpetual motion machines ever work. And then lastly is the 5.4 questions on page 93, numbers 1 to 2.